Hey everyone. So today we're going to be talking about trying to clean up your data. So when we get a data set, it's not always in the format or it doesn't have all of the variables that we need. And sometimes we've got things like outliers, problem columns, things that we need to get rid of. So we need to clean up that data set. And we're going to be talking about a package in R that helps us do all of that with a few simple functions. So the package is called the tidyverse, and one of the sub packages or functions within that is called dplyr, and it's got some functions that we'll use to do things like filter out certain parts of data or arrange our data, select certain columns, etc. So this will be part 1 of 3 on using the tidyverse to clean up your data. So let's just step right into R and get right to it. All right, so here we are in my R screen. And what you see here is that I don't have a script file open right now. So I'm going to create a new script simply for my tidying section right now. So I'm going to press on the little green plus arrow up here in the corner. You could also go up to the file menu. So I'm going to say I want a new R script, and that will open up this part of the panel up in the top corner. I can start typing my commands. So the first thing we need to do is we need to make sure that we've got the tidyverse package loaded. So we can use the command library tidyverse to load that library. Now, if you don't already have tidyverse installed, you're going to need to install it. And remember, we can install packages in 2 ways. The first is by going down to the Packages tab down in this bottom right-hand corner, and then clicking on Install and selecting tidyverse. Right? We can say, if we type in tidyverse, we can see we select that, and we can click on Install. The other way we can do it is using a text command, install packages, quote, tidyverse, quote. And we run that command and it will install that package. But I'm not going to run that because I already have it installed, but we still do need to load that package each time we restart R. So I'm going to run that either by clicking on Run, or I like to use Command or Control Enter to run that. And we can see down here in the bottom, it's loaded up the tidyverse, and we've got a bunch of different packages within tidyverse. And the one that we'll be using mostly is dplyr, and that includes a bunch of the functions that we're going to be using today. Now, one of the other nice things about these libraries is that they actually include data sets that we can use to manipulate. So if we just type in data, open close brackets, and run that, we can see that I've got a bunch of data sets already in my own folder, but there are data sets that are included with the base package, like Nile and Orange and all these different ones. MT cars is a classic one. And then there are other packages that are included with some of the functions that we loaded. For example, in dplyr, there's band instruments or band instruments 2, Star Wars. So there's a bunch of different data sets that we can use. And if we're looking for some data to practice on, sometimes some of these are really useful to open up and try and look at and try and practice with them. So I'm going to go back to here. So let's get on to tidying some data. So what we'll do first is we will load up the heights data set. And the heights data set is linked below, so you should be able to find that. It's called heights_long.csv. And remember, there's a couple of different ways we can load in this data. So one would be by clicking on the import data set up here in the top right corner. And we can click on from text base, And then we just have to find the data. Now I'm going to find it under my data folder. I'm going to scroll down to heights_long.csv. And I'm going to click on open that. Now, when it does that, it's going to name the file with the file name. Here, we're going to just call it, heights_long, like it's named. And it asks us, does it have a heading? We're going to say yes. We've got heading, and we've got height, and we've got sex. So we're going to say yes. And I often will click on strings as factors. This will be useful to us later on when we're starting to do some analyses. Then I can click on import, and we'll see it'll open up that data set so I can see what's in it up here beside my script. Now I can close that, and it doesn't mean that it's deleted it. It's just still here in my environment, and I can open it again anytime, either by using a view command, view heights_long. That will do the same thing. Or I can simply click on the little table-shaped icon up here in the corner, and it'll just do the same thing. It'll open it as well. Okay, so now we've got heights_long loaded up. Let's have a look at what that data is again. So we've got basically a bunch of heights, and we've got males and females. Now, imagine that we just wanted to take a subset of just the females. Well, one way we can do that using the tidyverse is by using the filter command. Now, all of the functions that are in dplyr, which is short for data plier, like a set of pliers that you want to manipulate something in the real world with, but dataPlyr, we're going to be manipulating data. All of those functions, they sort of use the same structure. And the structure would be, well, the function that you want to use, and this one we're going to be using filter. And then you have to tell it what the data set is. So I want to filter heights_long. So I'm going to hit tab and use that. And then you need to tell it what you want it to do. You need to give it an argument. So we're going to say filter heights_long, where sex is equal to F. Okay, so what that's going to do is say, I'm going to take this data set and just filter where sex equals F. Note I used a double equals here. And if I use a single equal is often used for giving some other variable of value. When we're asking it a logical question, does sex equal female, yes or no, we have to use a double equal sign. And if we don't use a double equal sign, an error will come up, and tidyverse is pretty smart, and it'll actually say, did you really mean 2 equal signs? And you can say, yeah, I did mean that, and you can try it. So if I do that filter, what we'll see in the output is it'll give me a list of my data that is only the females. All right, so that's nice. It's actually done a good job of subsetting my data. Now, of course, this only outputted it to the output panel here to the console. So if I want to save that into an object, I might want to call it heights F. And into that, I'm going to actually copy this whole thing and paste it. So into heights F, I'm going to filter heights long, where sex equals female. And now it's created a new object here up in my environment called heights F. There's 20 observations. If I open that up, we can see it's only female data in there. So I've been successful in subsetting my data to say I only want females. Now, another thing we can do is we can string multiple filter elements together. So for example, if I wanted to say, I'm going to copy this filter command just because I don't want to save it into a new object each time, but I could say filter heights_long, where sex equals female, and we could put and height is greater than 170. And if I run that command, now we see it filters where I've only got females and all the females that are above 170 centimeters tall. So this allows us to filter on multiple aspects of the data. You could use the same sort of command, but instead of an and, we can use an or statement. So instead of and, we use this vertical bar. Now this vertical bar in this case means or. So we could say filter or heights underscore long sex equals female, or height is greater than 170. Now, if you think, what is that going to do? It means that we will get anybody whose height is over 170, or everybody who is female. So if I select that, what you see is we've got now all the males whose heights are over 170, and all the females. So it's saying, if your sex is female, include that. Also, if your height is greater than 170, include that as well. So that's a nice way you can filter on multiple criteria. So another way we can use filter is if I type that in. Now instead, we're going to say where heights exclamation point equals. And this means does not equal female. And height is greater than 170. So in this case, we'll only get males whose height is greater than 170. So if I run that, you'll see all of the values that I get are males, and those are greater than 170. Now, this would be the same thing as running sex equals M, and height equals 170. But you can imagine if we've got, say, 3 categories. We've got M, F, and other, so non-binary. And we might want to say, we want to look at heights of anyone who is not male. So we could say not male, and that would give us female and non-binary as well. All right, so the next command that I'm going to be talking about is the arrange command. And this is also included in tidyverse. And what arrange does is it basically just sorts your data based on whatever criteria you give it. And this might be really useful if you want to start to look through your data for high values or outliers or other issues that might be included in that data. Then you can go through and filter if necessary. So the way we use arrange is really in the same way we just used filter. So we need to say arrange heights underscore long. And let's assume we want to sort by height. So we can just type in height. Now, if I run that command, what we'll see is that it has now sorted the data from lowest to highest. So 152 all the way up through 193. Now you can also use the same command. I'm going to just copy that and paste it below. And imagine you wanted it from highest to lowest. Well, all you need to do is put DESC, which means descending, and then height inside of brackets. So you need basically 2 sets because you need to close the first one and then close the second set of brackets. So I type that and we can see that it's basically done a descending sorting of that data, which is nice. Now what we could see is that it's actually got males and then females in here and then females and males and females. You might want to sort on 2 criteria. So for example, say we wanted to arrange or sort our data based on height, descending height, but first we want to do it on sex. We can just simply add that in as one of the arguments in front. So basically we're going to say sort on sex first and then in height descending. So if I run that, we see, okay, I get all of the females first because it will just do alphabetical order for text variables. So all the females in descending height from 180 down to 152, and then all the males in descending order from 193 down to 168. So you can use a range really to sort your data in a couple ways if you want to start to look at, maybe what are some of the, maxes and mins in your data, just sort of in a cursory type of way. Okay, so the last command that we're going to look at in this video is the select function. And select is simply the same idea as filter, except that instead of working on rows and filtering by some criteria, like say height is above some value, this will simply select just the columns that you want, but all of the rows in those columns. So you might get a data set that's got hundreds of columns of data, and you really only need like 3 or 4 or 10 of them. So what you can do is you can select just those ones and subset them out into a different data set, so you don't have to deal with trying to search through all of those columns that you don't need. So the way we do that is we can use the select function sort of in the same way. What we're going to be doing is we're going to try it out on a data set that I've got linked as well called mindfulness. So I'm just going to load it from my data folder using the read.csv command. But again, remember, you can use this import dataset function if you want. So I'm just going to create a new object, which is a data frame called mindfulness. And into that, I'm going to use the command read.csv. And I need to give it the path to my data file. So it's data/mindfulness.csv. And I like to also use the argument strings as, I need that to be in quotes, then comma, strings as factors equals true. Now if I run that command, we can see now I've got a mindfulness data frame. And what does it look like? If we look at this, we've got a bunch of different different columns that are called mind 1, mind 2, mind 3, etc. and stress 1, 2, 3, 4, 5, 6. As well as at the end, we've got age and gender. What these really represent are just maybe a Likert scale for different subjects. Each row is a subject. A Likert score for mindfulness and some questionnaire where the first item was just called mindfulness 1, the second item was mindfulness 2, etc., etc. And you might have 5 of those, 6 stress items. Looks like there's about 7 depression items, and then an age and a gender associated with those. So that's what the data set looks like. Now, imagine that we wanted to create just a folder. We didn't care about all of this. All we wanted to know was something about the gender and the age of our subjects. So we could create a new data frame, and I'll just use df as sort of like a temporary data frame, just so we can use it and look and see what happens to it. And I'm going to select from mindfulness Remember, these commands use the function name followed by the data set followed by an argument, which is what do you want to do to it. So I want to just select gender and age. So if I run that, we can see I've created a new data frame. And if I select that data frame and have a look at it, it just has 2 columns, right? So now that's been pulled from the mindfulness data set, and it's just got 2 columns, which are gender and age. Now, we may want to do something like, if we look at, again, back at this mindfulness, we want mind 1, mind 2, say we wanted all of the mindfulness items, mind 1, mind 2, mind 3, mind 4, mind 5. Well, one way we could do that is by typing them all in individually. Mind 1, mind 2, mind 3, mind 4, mind 5, like I have here with gender and age. We could also use mind 1 and then put a colon, mind 5. So you could say, I want the columns -1 all the way through -5. And if I run that, we'll see that now our updated data frame has just -1 through -5, which is nice. I'm going to close that down again. So maybe we actually want a data frame that excludes the mindfulness data. We don't want that. We just want the stress, the depression, and age and gender. So we could use the same command, but it's very easy. We just put some brackets around -1 and -5, and then hit a minus in front of it. So I want to select mindfulness and subtract from that -1 through -5. Now, if I run that command and I look up my data frame again, now we can see I just have the stress items, the depression items, and then age and gender. So what this has done is it's just selected everything except -1 through -5. But you could also imagine a scenario where you've got a bunch of different variables that are related to the same thing, like stress, but they're not nicely all lined up beside each other. And I don't want to say stress 1 through stress 5 because there's a couple mindfulness ones in between. So you could use a command instead that is something like select from mindfulness starts with, and then I need to just give it I said stress, didn't I? Starts with stress. Now it'll select anything that starts with stress. If I look back at my DF again, we can see I've only now got the stress items. And they could have been spaced anywhere throughout that data frame, and it will actually run that correctly. You could do the exact same thing, say if you wanted some items that end with the same thing. So instead of starts with, we can use ends with. So ends _ with, and it could be, in this case, I know that I've got various numbers on them. 1, 2, 3, 4, 5. So I just want all of the ones that end in 3 for whatever reason. So if I select that and we look back at our data frame, now what do we have? Well, I've got mind 3, stress 3, and C depth 3. Again, imagine if we look back at our mindfulness, I've got some items in here. Well, I want all these depression items. They don't start with the same thing, and they don't end with the same thing either. But they all do have depth in the middle. So what I can do is, instead of using starts with or ends with, I can use contains. So if I copy that, paste it there, and I'm going to select for mindfulness, contains, and then I'm going to put depth like this. Now, we can see now here, I should have all of the depression variables in my data frame, which is super nice. Now remember that you need to make sure that those are all correct. So if I had just done DE, that would give me a problem, right? If I think that that's going to be, that'd be all the depression ones. And if I run that and I use DE, well, you can see it's also selected gender because it also has a DE in it. So you want to be careful when you're using the contains because it won't always be the same things that are in there. All right, so that's the end of the first part where we looked at the filter and select and recode functions that are included within dplyr, which is in tidyverse package. And remember to always load up those packages each time you start R. And in the next video, we'll look at the mutate function, the recode function, and the summarize function. All right, check that one out.